Question 1. A. Differential equation. The equation gives us utt equals to c square uxx, ux0 equals to 0, u prime x 0 equals to 0. We Laplace both sides of the equation, so we got from the entry number 21 transform of derivative s square uxs minus s ux0 minus u prime x0 equals to c square uxs xs. So we know ux0 equals to 0 and u prime x0 equals to 0. So we plug in the value in the equation. Then we got this. Then we bring this side into this because we want to use a characteristic equation. So we have m square minus s square over c square. So we square root both sides. So we get m equals to plus minus s over c. So we plug in s over c equals to into the equation. So uxs equals to a exponent s over cx plus b exponent negative s over cx.
So for question 1b boundary conditions, the question gives us u0t equals to t exponent power of negative t. So we Laplace both of them from entry 14 in table of Laplace transform 3n e power of at equals to this. So where n equals to 1, a equals to negative 1, n equals to 1, a equals to negative 1. So we got u0 as equals to 1 over s plus a power of squared. When x approaching infinity, uxs equals to a as e power of infinity plus b as e power of negative infinity equals to 0. We know e exponent approaching negative infinity, we got 0. So we got a as e power of infinity equals to 0. A as equals to 0, so we plug in this value into here and we got b as equals to e power of negative s over cx x. So when x equals to 0, u0 s equals to 1 over s plus 1 square. So bs equals to 1 over s plus 1 square. So we plug in bs in here and we got 1 over s plus 1 square exponent power of negative s over cx. So for question C, initial conditions, we Laplace inverse all of this, and from entry 14 and 16 we inverse the Laplace equation here. So we got uxt equals to t exponent power of negative t delta t minus x over c. So from entry 24, for Laplace convolution theorem, so ft equals to gt, integration of 0 to t f tau g t minus tau d tau, uxt t 0 to integration of 0 to t exponent negative t delta t minus x over c d tau.
Question 2, after the information given, question 2 asks us to derive the eigenfunction of xn of x equal to cos n plus 1 over 2 pi x using the separation variable. Okay, so it's also note that assume that the eigenvalues of positive. Okay, now first of all, we know that we have to let the u of x of t equal to x of x and t of t. So we will get the equation like this. We derive t, which means the x t derive of t, and then ux, which means derive of x t, and if uxx, it means that derive 2 times of x t. Okay, and then we will get like this equation. Okay, and then you have to equate equal to constant. Okay, next let's k equal to negative pi squared. Okay, after that we use separation variable until you get t of t equal to to the power of negative lambda to negative negative lambda squared t. You also will get x of x equal to a sine lambda x plus b cos lambda x. Therefore, you will get the answer after you combine xx and t of t that you just found just now. Next, we have to apply the boundary condition, which we all know ux equal ux of 0 t is equal to 0. Okay, and then we just using the information that we get just now. Okay, we have to differentiate it until you get like this equation. Okay, and then we equate that x equal to 0, and then we get a equal to 0. Now when you have found a, next we have to find what is the value of b. Okay, oh no, the value of b. Okay, and then we will get that lambda n equal to n plus 1 over 2 pi. Therefore, you will get this answer to find a is equal to 0 and b is equal to 1. So xn is equal to cos pi n x. So like the question asks, the answer will be like this.
Okay, for question 2, question B asks us to show that the integration of xn x xmt dx with the limit of 0 to 1 equal to 1 over 2 for m equal to n and 0 for m not equal to n. Okay, from the previous solution 2a, we got xn x equal to this equation, and xmx we got this equation, but this equation is not true. The data that we key in are incorrect, which is it should be cos m plus 1 over 2 pi x dx. Okay, for solving question B, we need to use the formula of product to sum formula, which is 2 cos A cos B equal to cos A plus B plus cos A minus B. Okay, in solving the first part, which is we want to know that 1 over 2 for solution of m equal to n is equal to 1 over 2. For the first part, we want to find that m not equal to n equal to 0. So we just integrate cos n plus 1 over 2 pi x cos m plus 1 over 2 pi x dx. Okay, by solving this, all of this equation, we got m not equal to n equal to 0. For solving m equal to n, which is 1 over 2, we just um, we just we just plug in all the data, all the previous data in the in the in the equation, which is it should be cos n plus 1 over 2 pi x cos n 1 over 2 pi x, because we replace m equal to n, since the question asks us to find m equal to n. Okay, after solving all the equation, we got m equal to n equal to 0, n equal to 1 over 2. Hence, it is proof that the integration of x and x empty dx with the limit of 0, 1 equal to 1 over 2 for m equal to n, and 0 for m not equal to n. For question C, the question asks us to show that the solution uxt equal to the summation of n equal to 0 to infinity cn cos n plus 1 over 2 pi x exponent to the power of negative n plus 1 over 2 pi squared t, where cn 2 over pi squared n plus 1 over 2 squared. When the initial condition are u x 0 equal to 1 over x. Okay, u at 0 equal to 1 over 1 minus x equal to will be our function. So for the previous solution, we got x and x equal to cos n plus 1 over 2 pi x. Okay, for solving this solution, let bn equal to cn, uxt equal to cn exponent to the power of negative pi squared t cos lambda x, where lambda equal to n plus 1 over 2 pi. Okay, the question asks us to show that your nxt equal to the summation of n equal to 0 to the infinity. So we need to use this formula to find the cn. Okay, by using this formula, we just plug in the equation for fx and the equation for x and x. Okay, just plug in into the formula. Then we need to integrate this formula. Okay, if you can see, we differentiate we divided the solution into two, which is the first one is the integration of the integration of cos n plus 1 over 2 pi x dx with the limit of 0 to 1 equal to equal to this solution. And for the solution for integration of this question, we got this one. Okay, next we combine both of the solution to the previous formula cn, and then we got the solution for cn, which is 2 over pi squared n plus 1 over 2 squared. Okay, it is proof that uxt equal to the summation of n equal to 0 to infinity cn cos n plus 1 over 2 pi x exponent to the power of n plus 1 over 2 pi squared t, where our cn is 2 over pi squared n plus 1 over 2 squared.